Download this code from codegive.com, link in the description below. OK, let's tackle a challenge scenario where you're working with Raylib in C, or C++, the concepts apply, and a supposed support library has some issues, specifically in 2D contexts. This often manifests as unexpected behavior with drawing, collision, or transformations. We'll walk through a practical example, identify potential problems, and offer solutions. Scenario: the broken 2D support library. Imagine you're building a simple 2D game with Raylib, and you've decided to use a support library to handle some common tasks like entity management and collision detection. This library, let's call it entity_utils.h, provides functions for creating entities, moving them, and checking for collisions. However, you suspect the collision detection is flawed. 1. Code setup, project structure. First, let's create the basic project structure. 2. Entity_utils.h, header file, the problematic library. 3. Entity_utils.c, implementation of the support library. 4. Main.c, your main game code. 5. Makefile, optional, but recommended for easier compilation. Explanation of the setup. Entity_utils.h declares the entity structure and function prototypes. This acts as the API of our, potentially flawed, library. Entity_utils.c implements the functions declared in entity_utils.h. The check collision entity function is intentionally written incorrectly. It calculates the distance between the entity positions and compares it to a combined radius, using width, making it a circle collision check instead of a rectangle collision check. *main.c* your main game loop. It creates two entities, moves the player based on keyboard input, checks for collisions using the broken check collision entity function, and draws the entities to the screen. *makefile* a simple makefile to compile your code. 6. Compiling and running. 1. Install Raylib*. Make sure you have Raylib installed correctly. The exact installation process depends on your operating system. Check the official Raylib documentation. 2. Compile*. Using the makefile, if you created it, make manually with gcc src/main.c/entity_utils.co bin/mygame include Raylib lm wall. 3. Run*. Using the makefile, make run manually, bin/mygame. Identifying the problem, incorrect collision detection. When you run the game, you'll notice that the collision occurs when the entities are still quite far apart. The player changes color to green before it visually overlaps with the obstacle. This indicates the incorrect collision detection. 7. Debugging and fixing the broken library. The key to fixing this is understanding that we need a rectangle intersection test, not a distance-based test. Raylib provides a handy function for this, check collision recs. Here's how to fix check collision entity in entity_utils.c. Explanation of the fix. 1. Create rectangle structures. We create two rectangle structures, rect1 and rect2, representing the bounding rectangles of the two entities. The rectangle structure in Raylib takes the top left corner coordinates, x, y, width, and height. 2. Check collision recs, we use Raylib's check collision recs function, which efficiently determines if two rectangles are intersecting. Recompile and run. After making this change, recompile your code, make or the manual compilation command, and run the game again. Now, the collision will only be detected when the rectangles actually overlap visually. 8. Advanced considerations, why libraries break and best practices. Version incompatibilities. A library might have been written for an older version of Raylib, and some functions may have changed signatures or behavior in newer versions. Always check library documentation for compatibility. Undocumented behavior. Sometimes, libraries have functions that aren't fully documented, leading to unexpected results. This is where reading the library's source code, if available, becomes essential. Bugs. Libraries, like any code, can have bugs. The collision check in this example was an intentional simplification to illustrate a bug. Real-world libraries might have more subtle errors. Assumptions. A library may make assumptions about how it is used, which may not be clearly stated. For example, it might expect entities to always be positioned with their origin at the top left corner, which might conflict with your game logic. Lack of updates. The library might simply be unmaintained and has not been updated to fix bugs or improve performance. Best practices for dealing with broken or unreliable libraries. 1. Read the documentation. Thoroughly read the library's documentation, if it exists. Pay attention to function parameters, return values, and any known limitations. 2. Examine the source code. If the source code is available, take the time to read it. This can help you understand how the library works internally and identify potential issues. 3. Write unit tests. Create unit tests to verify that the library functions behave as expected. This is especially important for critical components like collision detection. A unit test would involve calling the check collision entity function with various entity positions and sizes, and asserting that the result is correct based on your expected behavior. 4. Wrap the library. Instead of directly using the library functions throughout your code, create a thin wrapper layer around them. This gives you more control over how the library is used and makes it easier to replace the library if necessary. This is an example of the facade design pattern. 5. Implement your own if the library is truly broken or inadequate, consider implementing the functionality yourself. This gives you complete control and allows you to tailor the code to your specific needs. In our example, this might mean creating your own collision detection functions. While it takes more effort initially, it can save you headaches down the line. 6. Contribute back. If you find and fix bugs in an open source library, consider contributing your changes back to the project. This helps improve the library for everyone. 7. Look for alternatives. Search for other libraries that provide similar functionality. There may be a more reliable or well-maintained alternative. 8. Start simple. Always begin by integrating the library into a small, isolated part of your project. This will make it easier to identify and fix any problems. 9. Use debugging tools. Take advantage of debugging tools like GDB, or your IDE's debugger, to step through the library code and see what's happening. 10. Community feedback. Seek feedback from the Raylib community, forums, Discord. Someone else may have encountered the same issues and have a solution. Example of wrapping the library. Instead of directly using check collision entity, you could create a function like this in main.c. Then, in your main.c game loop, use myGameCollisionCheck instead of check collision entity. This allows you to add pre or post processing to the collision check without modifying the original library code. It also centralizes the usage of the library function, making it easier to replace later. In conclusion, dealing with broken libraries is a common challenge in software development. By understanding the potential problems, employing debugging techniques, and following best practices, you can mitigate the risks and ensure the stability of your Raylib projects. Remember to isolate the problem, test thoroughly, and be prepared to implement your own solutions if necessary. Good luck.